Okay, so in this one, we're actually going to take a step into two of the most commonly used probability measurements of probability, and the first one is binomial probability distribution. Just to explain binomial, so there's two um, what makes or what sets up something to be a binomial probability distribution is first there has to be only two possible outcomes. Um, Now, majority of the time, we actually, and you'll see here, um, the possibilities would be success or failure. A lot of time in business, we can set up a lot of um, probabilities to be either successes or failure. Now, it doesn't matter what a success doesn't necessarily have to be a positive. Um, an example would be for like airline companies, if they wanted to observe how many bags were lost per flight, and they could keep track of that. And what they would do is they would actually call a lost bag a success. So it's not necessarily a positive thing. It's just that we can look at anything in those terms as being a success or a failure. So a binomial probability first has to be one of two possible outcomes. In our case, we're going to talk about success and failures. The second rule is that we look at binomial as looking over a set number of trials. So in this case, we're actually going to look at a number of subscribers, but um, once again, I'll kind of explain a little bit further with as we get into this problem. But so I already have this set up. So we're going to look at an example that is actually on slide 20, which is the probability of X successes in a binomial experiment. So let me read this, and then once again, I'll talk about the two of the rules with binomial probabilities. But we have a cable company believes that their new promotion will convince 20% of satellite television subscribers to sign up for cable. If the company is correct, what is the probability that 2 out of 8 randomly selected satellite users end up switching to cable after hearing the promotion? Okay, so let's talk a little bit about the two main rules. The first one is the possible outcome. So in this case, they can either subscribe or not subscribe. So in this case, they're looking at subscriptions as a success. So what I've done here, oh, and the second one is the number of trials. In this case, it says, what is the probability that 2 out of 8, right? So there's an actual set number of trials. We're looking at 8. So what I've done here is I've set up 0 through 8. So what this looks at is what is the probability that 0 out of 8 would sign up? What's the probability that 1 out of 8? What's the probability of 2 out of 8? What's the probability of 3 out of 8, 4 out of 8, 5 out of 8, 6, 7, 8 out of 8? Okay, so what we're going to do is we're actually going to find the probabilities attached to that, and we're going to use the binomial distribution formula. So, and I'm going to kind of point out a couple things here just so you kind of quick purposes. So you can go to the formulas, or you could type it in. Once again, it depends on your comfort level and what you actually use. But I'm actually just going to go through the formulas, statistical, and I'm going to look for my binomial dist, and I'm going to click on it. So you should have this dialog box pop up, and there's a couple things here that we want to look at. So the first one is number S, and this is what we call the number of successes. Now, I could type in 0 in here, but in order to copy my formula, I'm actually going to use cells for some of these. So for number of successes, I'm going to come over here and click on 0. So if you notice, instead of putting in a number, it puts in a cell reference. Okay, and once again, this is for copying the formula and dragging it down, because that's something that's going to change. So if I want this box over here where it's the probability of 1 success, I want it to be the number of successes, I want it to be 1. So that's why I used 82 instead of typing it in. Number of trials, it's always going to be out of 8, so I'm actually going to type 8 in. So for as soon as I pull this down, 8 will be attached to all of these. The probability of success, we've already said, or we looked at, they convinced that 20% of satellite television subscribers sign up for cable. So we have 20% as our probability. So what we can do, wait, let me see, they're convinced, believes that their new promotion will convince 20% of satellites to sign up for cable if the company is correct. What is the probability? Yeah, so we have 20%. The next, and I'm going to type that in, and I'm going to type that in as 0.20, which once again is 20%. Now down here, cumulative, we're actually going to do some cumulative calculations, but for this, I actually want you to put false, or you can also put 0 in here. I'm going to click OK. So cumulative, it would be like adding them all up, which we don't want at this point. We want specific outcomes. So I'm going to click OK. So my next step is to, since I have everything kind of set up, I'm actually just going to go to the bottom right here and copy and paste that formula. And as you'll see, we have all of these probabilities. Now, just to make sure, I'm going to sum all of these, and because we have, you know, the probability, these should all equal 1 when we add them up, or 100%, and it does. So I'm pretty good there. Okay. So now this question, literally, we could, no matter what the question was asked, if they're looking for an exact, meaning what is the probability that 2 out of 8? Well, we would say that there's a 0.293 probability of that occurring. If the question was, what's the probability that 5 out of 8? So I'm going to 5, and I would say, well, there's a 0.009175 probability that 5 out of 8, 0 out of 8. So this is if we're looking for a specific number of successes out of those 8 trials. Okay. Now, another way that we can use this is in the cumulative aspect. So what that would be, and you have to listen to the wording. So if the question was, what's the probability that 2 or more would subscribe? So what that means is we want to know 2, 3, 4, 5, 6, 7, and 8. So what we'll do is we'll actually sum all of those. So I would actually say, if I wanted to know that probability that 2 or more, I would highlight the 2 down to 8, and I would hit OK, and I'd have a 0.496684. So once again, that's 2 or more. 2's included in that. Now, if the question was stated this way, what's the probability that more than 2 would subscribe? So then the wording takes it slightly different. More than 2 would actually start at 3. So what I'm going to do is I'm going to sum the probabilities from 3 up. And I got 0.20. Okay. So once again, it's in the wording, whether or not you're including that number or not. But that's the idea behind cumulative, is that we're adding those probabilities. Just in module 3, where we talked about probabilities and we talk about adding probabilities. These are mutually exclusive, so there is no intersecting, meaning you can't have 1 success and 2 successes, meaning you either have 1 success or 2 success or 3 success. So when we want to add, or when we talk about what's the probability of 1 or 2 or 3 or 4 or 5, then we're adding those, and these are the probabilities that are attached to those. So once again, this is what we call our binomial probability distribution. And in actuality, the last thing we're going to do here is I'm actually going to talk about the mean of a binomial probability distribution. It's pretty simple if you think about it. So what I'm going to do is I'm going to restate the question and see if you can understand this, and then I'm actually going to do the math. So it states that 20% of subscribers will sign up for cable once this promotion airs. So 20% of subscribers will, of users will subscribe. So if there are 8 users that we're looking at, what is the average number of users? So out of those 8, what's the average number of users if 20% of them are going to subscribe? So in order to find the mean, or the expected value of a binomial probability distribution, we simply take the number of trials times the probability of success, and we have 1.6 on average will subscribe. So this is the pretty simple. There's a couple other problems there that you can perform. But this is the once again, this is the idea behind binomial probability distribution. If you guys have any questions, please feel free to reach out.